Let's talk about one of the major themes of this unit on polynomial functions, and that is what we call the zeros of the function. The term zero is a very useful term. It has lots of definitions. It has lots of connotations. There's other words, okay, that are used to describe zeros. Sometimes zeros are referred to as roots, and we'll talk about that, okay, here in a second. But these terms, roots and zeros, are interchangeable, okay? Here are three, and if you want to pause this and write these down, here are three definitions or ways of interpreting what the zeros of a function are, okay? One is that zeros are the x values that produce an output of zero when they're plugged in, okay? So think of it this way, right? When you have a function, any function at all, okay, let's take something really simple here and say x minus 2, right? That graph would look like this with a y-intercept of -2, okay? Where y-intercept of -2 down here, its x-intercept is right here. The coordinates of that point are 2, 0, right? How do we know that? Because if I take the number 2 and I plug it in here, 2 minus 2 is 0, right? So the zero of this function would be x equals 2. So a zero is typically expressed as an x value, not as an ordered pair. But when you look at it as an ordered pair, you see that y coordinate of 0, okay? I'm going to get rid of this because there's going to be a whole bunch more going on this page. But that's one interpretation of what a zero is. It's a root, okay? It is an x-intercept. We see that down here. The x-intercept of the function when it was graphed, right? It was at 2, 0. And if we set the equation equal to 0, okay, that function that we had where it was f of x equals x minus 2, if we set the function equal to 0, we're making the y coordinate 0 here, right? We're taking f of x and replacing it with 0, and then we solve for x, so we get x equals 2, right? So there's three different interpretations. If I want to know the zero of a function, I can graph it and I can look for that x-intercept, okay? I can plug numbers in for x and figure out which one of these makes the function equal to 0, okay? Or I can just graph the function and find its x-intercept. So just to reiterate, x-intercepts are also referred to as zeros, okay? Which are also, come on, Jeremy, that was bad. All right, let me do that again. Tried to get cursive on you. My bad. Don't do cursive on the pad here. X-intercepts, also known as zeros, also known as roots. Okay, why are they called roots? There's a bunch of different interpretations. I like to think of it like this. Where do the roots start on a plant once you get underneath the ground? So wherever it reaches the ground, okay, and then whatever happens beneath here, the root starts right there. That's the way I've always thought of it, okay? Let's take a look at an example here. So we have a function g of x is equal to x squared plus 3x minus 10. One of the things you're going to be asked to do in this unit is find the zeros of the function, okay? And what that means is any one of these would work, right? You could try. I wouldn't suggest this first one, but you could try to figure out the values of x that if we plug them in will end up being 0, okay? Or the second definition, solutions to an equation that's been set equal to 0. So we could say, okay, here's my function. If I set this equal to 0 and solve, this will help me find the zeros, right? The third option, which is the easiest, is just to graph this and find those zeros, find those x-intercepts, okay? But so again, if you look at just the graph, which I already have done here, you can see, okay, I've graphed the function already. You can see where the graph crosses the x-axis at -5 and at 2. So we know that the zeros are -5 and 2, okay? Done. But from here, from this standpoint, let's talk about solving this, okay? When it comes to solving this equation for x, you've really got two options. Well, what's your first option? Your first option is to graph it. And there's no shame in that game, okay? If you want to graph it and find the x-intercepts, fine. I will tell you this. The expectation, because you're in pre-calculus, is that you're going to do some work here because you're going to need some of these algebra skills going forward, right? The second option, how do you solve a quadratic that's set equal to 0, right? Your first inclination might be to use the quadratic formula. And if you have a quadratic, that'll work, okay? This is a quadratic equation. We can use the quadratic formula. Problem is, this only works for quadratics, okay? We don't have a cubic formula, all right? There is no quadrinomial formula for this. If it's squared, right, then we can use the quadratic formula. If it is not squared, we cannot. So the fallback option and the best option and the option that we're going to use the most often is factoring, okay, which is why we spent so much time doing that at the beginning of this unit. Okay, so when it comes, or earlier in the year, when it comes to factoring, we have a quadratic, quadratics, trinomials, or even degree trinomials. If they're factorable, we're going to try to factor them into two binomials. We need two numbers that multiply to be -10, but add to be +3. Those two numbers would be +5 and -2, right? Our factoring skills have to be good in this chapter. We're going to factor a ton of polynomials here, okay? So now we have this. We have, and this is what's called the zero product rule. If you want to write that down, okay, the zero product rule, right? But this is common sense, even though they gave it a special name. The zero product rule states, okay, if I have two things that are multiplied together and their product is 0, one of these has to be 0. So once we get to this place, we take our factors separately and we say, well, maybe this is equal to 0, or maybe this is equal to 0, okay? If we subtract 5 from both sides over here and we solve for x, we get x equals -5. If we add 2 over here, we get x equals 2. And what did we say from our graph? What were those x-intercepts on the graph? -5 and +2, which is what we found by doing the algebra here, okay? So the zeros, keep in mind, they are these x values. We can always attempt to factor any function that we're given. Quadratic formula, maybe if it's quadratic, but the fallback, the go-to that will work in almost every instance is if we set the polynomial equal to 0 and then factor it with the factoring skills that we've acquired throughout the years. Set each one of those factors equal to 0 at the end, and you'll have your zeros for the function.